Good morning, my name's Mark and I'm here to do a presentation for you today on the OSI Reference Model. The reference model has 7 layers, each of which has a function in the data that we send and receive through our computers. The OSI model has been around since the 1980s and is still going to this day. That's over 30 years later. The hierarchy of the OSI model is layer 7 application, 6 presentation, 5 session, 4 transport, 3 network, 2 data link and 1 physical layer. I'll be giving a brief description of each one of these layers as I go through the slides. Finally, a working model of a packet being sent to the source and a description is shown at the end. This layer defines all the data and does what it needs to do to the data so it can be presented, so it can be visually recognised by ourselves. This layer then sends the data to the presentation layer. Applications on this layer will be Telnet, FTP, file shares, Internet Explorer, Firefox, Opera, games like Doom and Quake through networks, and Messenger and MSN and Google. Layer 6, the presentation layer, performs communications between applications layers, between the application layer and the session layer, translates all the data it receives into the from the local PC, and controls cross-platform data in a language that is understood by all local PCs. One example is the conversion of a WAV file to an MP3. Layer 5. This layer can also manage multiple connections for applications to and from hosts. This layer also communicates with the presentation layer and the transport layer. Layer 4, the transport layer. This layer communicates with the session and network layers, transports data into streams, finds errors of lost data and then recovers the data and resends it, segments, stems and data into transport units, transports reliable data through TCP, and data sent through UDP is unreliable. And this layer's main role is errors. If a packet is lost, and any data in the layer is responsible to recover the damaged data from the data loss. Layer 3, network layer. Routing is handled at this layer. Before routing can take place, the data will need to be prepared for transmission. The following are its functions. Data from the transport layer needs to be encapsulated into network layer data unit. The networks and hosts get managed for routing at this layer. This layer needs to communicate with the transport and data link layer. Protocols at this layer are IP, Internet Protocol, Internet Control Message Protocol, ICMP, IGMP, IPX and SPX. Layer 2, data link, establishes a logical link between the source and the destination PCs. Frame sequencing and numbers have been used for demonstrating this. I have used 9 numbers in a mixed up order and 9 numbers in a sequence order. This demonstrates them putting them back into order. The above shows the example of sequencing in the correct order. Data link also recovers from errors that can occur from the physical layer. Layer 1, physical, deals with physical media between the source and destination, whether it's wired, fibre or wireless. And finally, the OSI Reference Model. This has got the layers from left to right with a virtual link, green pathway for send message and a yellow pathway for receive message. The send message will go down the green pathway and be received, and then the destination PC will then send a receipt back to the source PC, and if any others occur they will be contacted via the virtual link, which will re-establish the data that was lost and resent, so the message can carry on and end up in its destination in its true form.